Tyler.
Hey everyone, my name's Tyler. As Chris said, I work with Tom Tripp, full stack developer. Hyper, we use a lot of our code's already up on the front web, just with Nest and Arweave, so just coming here to learn more about Web3 and see what's out there.
I'm John.
John.
I don't really know what half of those words were.
You can just start over since the recording.
So I'm here to learn
Okay.
more about all of this.
I'm Dirk. I work in education and I'm an eager learner.
Okay.
I'm Kristen Bennett. I work at Meeting Street Schools. It's a nonprofit, and we are thinking about taking crypto donations, so I'm trying to learn more about blockchain.
Okay.
My name is Sean Worthy. I work at Mead Street Academy, right 500 yards away from here. Director of school operations, and similar to Kristen, have an opportunity for a crypto donation. I'd like to learn more.
Great.
I'm Dondra. I work for CarePoint. I'm a developer.
Hey.
The application.
Great. Thanks.
I'm Jim. I'm a management consultant. I work with companies trying to apply technologies to new best business practices.
Great.
So Paul Flig, I'm with Rackspace. Done a little bit of research on my own around blockchain and decentralization. Just here to learn more.
Great. Welcome.
Michael Whitfield. I've got a company called Green Roof Outfitters, and we do manufacturing of many deck products. And so we may be exiting soon, so I'm kind of looking for something else, and I know nothing about this.
Nice. Welcome.
So I'm Dan Miller. This is Blake Dean. We work, I'm the CFO. He's the controller of a distributed ledger tier 1 platform. They're a Hashgraph.
Okay. Hashgraph.
So, we know a little bit about this, but looking forward to maybe going back to the basics a little bit. But we skip to the advanced stuff, but we don't really spend as much time on it, so we're looking forward to it.
Okay. Great.
I'm Richard Saranto. I'm work for a consumer product company. I'm a hodler, just wanted to learn more information about blockchain.
I'm Mark Raver. I'm an angel investor with tech companies who got started specializing in crypto and companies and stuff. We actually maybe learn about it.
Good. Good.
Any way I can use my experience, like a portal architect, interested in different people at here, and particularly wrapping my head around the whole idea of smart contracts.
All right.
Jim Kirstein, just trying to find a better understanding of this.
Hey everyone, I'm Jackie Colhead. I am based out of the tech center here in Marcus. Our app, ResRev, replaces resumes with video to get you to the person faster, like with LinkedIn and TikTok ad baby. I'm just here to grow my understanding of blockchain, crypto, and all that good stuff. Tom's an amazing teacher, so happy to be here. Thank you.
Thanks.
Paul Turner from Virtual Merit, also a house here at the Tech Center. We are sort of researching the virtual and augmented reality. Most interested in part 3,
Okay.
intersection of augmented reality and NFTs.
Yep.
And the impact on the art world.
Nice.
Lynn Whitfield, operations manager here at Southern River Corridor, just trying to learn all about it.
Thanks.
Corey Cooper, Digital Corridor and Cybersecurity Product Manager.
Hi, I'm Jess O'Brien, the executive director of the Newport Digital Corridor, across from Digital Corridor, school president for it, so just here to learn stuff.
And did you just walk in? Yeah.
Marcus back in Mead Street Schools, just here to learn more about blockchain and the whole crypto world. Really
Great.
excited.
Great. Well, thank you all for coming. Again, we have a short time today, and I think some of the experts, this will be kind of basic stuff, but hopefully you will learn something today, and please feel free to interrupt me, ask questions. Again, there's a lot of stuff, and what I'm going to try to do is stay at the crust level, if you will. If you think of this rabbit hole of multiple layers, we'll get a little technical, but if I get too technical, pull me back up. I'm Tom Wilson, CEO of Hyper. We have a software as a service for developers and startups to help them build apps against services like data storage, search, queues, and cache. And if you are into startups or know developers, please ask them to check it out. So I've titled this series Decentralization, mainly because I've noticed and I'm seeing this movement from centralization, where we put everything in maybe one company or one cloud, and there is a movement of technology that's pretty exciting from the development space of this idea of decentralization. And part of that is the blockchain. So what we're going to talk about today is just a high-level view of kind of what I see as decentralization. Then we'll really dive into kind of the three core pieces of blockchain technology and spend some time on digital wallets. And at the end, hopefully demonstrate a transaction between two wallets. So again, if you're able to participate on the Miro board, that's great, because I think that'll help us with the demo part at the end. And if you're not, and if these slides are not big enough, just let me know and I'll try to raise the font. Okay. So, introduction to decentralization. If you think about it, back when computers first started, everything kind of started in this centralized model. If you're as old as I am, you may remember doing mainframe development where you maybe punch cards or maybe worked on a terminal and you would send it to Chicago or New York, and that mainframe would compile your code, run it, and then a print job would show up, right? And you would have to wait in line for your print job, which would be your output. That was, kind of slow feedback loop. And PCs came around the late 70s, early 80s, and kind of changed all that, right? And went to this decentralized computing platform. People could do programming in their homes, build applications, use spreadsheets in their homes. And a lot of people at that time thought that was crazy. Why would you want to buy a computer and put it in your home? That's just something a bunch of nerds from IBM uses, kind of thing. And then we had this transformation as far as networks, because you had all these PCs all scattered, but they couldn't talk to each other. And then you had these dial-up modems. Does anyone remember the dial-up modems? And we went from a local area network to a wide area network to now the internet, which is by itself decentralized, right? It's computers all around the world connecting and talking to each other, and it's a distributed computing system. Now, there's certain technologies that have been developed also in that path, right? So you would have a terminal and communicate with the mainframe, and then client server was big in the 90s. If you remember object-oriented programming and the 32 to 62-bit kind of transition, everything was client server. Databases were getting popular. There was Sybase, and then Microsoft came out with Microsoft SQL Server, which kind of was a borrow of Sybase technology maybe back then. But you would code and distribute code for the client, for the PC, and it would connect to a server. Then we started moving into web applications, right? And technologies started to emerge like peer-to-peer technologies like BitTorrent, and Napster was probably one of the first ones where people were trading music without central authority. And then blockchain was launched, I think, 2008 or 2009 by Satoshi Nakamoto. And that's really started to change a lot of things. we started to realize that we can exchange, value in a peer-to-peer way and keep it secure and run through all the potential attack vectors that you have, because on the internet it's completely open and it's very easy to copy data. So I think the idea of decentralization is to accomplish some task, transaction, thing without a central authority, right? And I kind of see it as a spectrum. You have centralization on one end and decentralization on the other, and I think it's just a large pie. So as we move forward, I don't think centralization is definitely going to go away. I just think there's just going to be multiple kind of pieces on that spectrum. Does anyone have any thoughts on that? Does anyone disagree with that assessment? Cool. So I like to kind of break down some history, recent history of the web platform. The web is where I live and breathe, and I think it's the most ripe for change with this technology. And you may have heard the term Web 3. So I'm going to try to unpack that a little bit and first talk about Web 1.0. If you remember back in the mid-90s, there was no Comcast, there was no Facebook. Everything on the web, you would connect to your local ISP via dial-up, right? And you would, write some HTML, maybe FTP it to a server, or maybe you would run your own server in your home, right? But at the point, it was all protocol driven. Web 0.0, anyone that knew how to code HTML and knew the protocol HTTP or other protocols could publish content and leak to other content. Well, one of the challenges with that was it's completely open. There was not a lot of security, not a lot of trust, and but at the same time, it was hard to get into because you needed to know about ISPs. You needed to buy computers with a modem. You needed to set up and learn how to code in language and learn HTML and HTTP. So it wasn't super hard, but it definitely wasn't mainstream. And then Web 2 came along, and I want to say around 2004, but Microsoft really drove the change earlier than that in kind of 2002, 2003 with DHTML, dynamic HTML. But what Web 2 really did was allow us to bring applications to the internet. Before that, a lot of the functionality was, kind of read-only websites. And there was not much interactivity. You would download an app or go to a store like Egghead Software and buy software, right, and install it. If you did taxes, you would buy tax software every year, install it on your computer, and work through that. So Web 2 really started this digital transformation, where it started taking things that we do physically, like go to stores and buy things, digitally. And I'm sure everyone is doing the majority of their Christmas shopping on Amazon this year or on the internet. Not much of going into stores. So client-server applications went web-based. I think everyone agrees that the web won in that kind of world. Like, you don't go and buy software to store anymore. You just go to a website and fill out some information, log in, and start using it. Social media. So the interesting thing about social media is, that made everyone a publisher, right? Everyone could publish content. And the cloud infrastructure as a service. You no longer had to run your own data center if you were providing service. You could use Amazon Web Services or Azure on Microsoft, et cetera. And then finally, mobile basically, put the entire internet, if you will, in the palm of your hand. So, and that's kind of where we are today for the most part. That's where mainstream is Web 2. And what is showing some promise, well, first off, why do we think we need Web 3? Does anyone want to answer that question? We've got Web 2, we've got all this great stuff. Why do we need something like Web 3? Yep.
Well, I think one is speed and then performance and cost. I guess that's three.
Yep.
So, if you can eliminate the middleman by through using technology decentralized, you can obviously cut out the cost of those people that are participating. You can also cut out the time that it takes for them to process the transaction. So I think those are.
Yep. Any other?
About more devices, more sensors coming on.
Yep. Yeah, those are all great. More devices, more sensors to reduce cost, create speed, reliability, right? So one thing with decentralization is you have all of these computers working together. If half of them go down, you're still good, right? So if you have one central computer and it goes down, I think Facebook went down a few weeks ago, right? And it's massive. That probably frustrated a lot of people. So there's that reliability, capacity. I would like to bring out at the protocol level, and we'll talk protocol and service. So the protocol level is like the common network level, and then the service may be a Facebook or maybe a Google level. But I think Web3 has the potential to bring identity and trust at the protocol level, right? So right now, the internet by default is insecure. You have to go to HTTPS, and that starts your secure transaction. But it wasn't always that way. We kind of duct taped that protocol on top of HTTP. I think Web3 has the potential to bring trust and identity into that protocol level. Is everyone any questions about that?
Yeah,
Sure.
I'm struggling a little bit with the concept of the identity factor. So
Okay.
when I go to my bank, they send me a real-time code to verify who I am. Is that what we're talking about?
Yeah, and I think we'll unpack that over this course, but absolutely. How many in the whole world? How many people are there? 7, 8 billion. Right? How many people in the world are unbanked that don't have a bank account? Yeah, at least 1.7 billion. That was the latest number in 2018 that I got, and it's probably increased that. So I think that the identity concept we'll unpack, and hopefully you'll understand. But yes, I understand at this point it could be a leap. But hopefully I can take you down this rabbit hole and help you understand what I mean when I talk about identity. So I think if you go on the internet right now, the way that you create your identity is, probably through some sort of email address, some sort of two-factor authentication, some sort of login and password, right, for each service. And that's how, once you get through that service, you feel like you're in a safe space. But if you aren't through that service, you're kind of in this no safe land of the internet. Web3 has potential of moving that login password down to the protocol. So when you connect, you're in that network and your identity is solid, right? And you can have things without having to rely on a specific service. In other words, you could have one identity for a Facebook, a Google, a Amazon without having to remember multiple passwords. Does that make sense? Okay. So let's hold that. and what I really wanted to do is kind of just start you thinking about that, right? So what if we could have all the things of Web 2 without having to depend on a central service? And I think that's really kind of the promise of Web 3.
So your concept here of central service is like the bank or the app?
Central services is central service, right? It's a single point of failure. So it could be an app, it could be a bank, it could be a service provider, anything that does transactions on the internet. In terms of Bitcoin replaces the bank, right? It gives you a digital bank where you can store your value in a wallet, and we'll talk about that, without having to work through a bank. And you can send transactions to other people that have Bitcoin, send money to them without having to go through a bank. So yes, a bank is a central authority. The central bank, the Fed, that's a central authority.
What's the timeline on Web3?
I think it's rolling out now. I think there's a lot of stuff. I think it's early days. So there's the other thing, let me just do a caveat. With any kind of new innovation, there's a lot of hype. There's a lot of hype out there. There's a lot of scams. There's a lot of noise. So it's really hard to measure with all that hype what is going on. But I would say that right now, and maybe these guys can clarify, but I would say that we're at a kind of a 1% stage, a very early adoption stage. And in the next 5 to 10 years, the trajectory is to go to mainstream. So if you think about Amazon started selling books and everyone kind of thought, what's this hippie from Seattle selling books online around 97, 98? And everyone was, kind of making fun of that prospect. And then it was 2002, 2003, I think the mainstream kind of started to realize, well, maybe this internet thing is something. And you had a bubble, right? You had pets.com and all that in the early 2000s. But once all that kind of settled, you kind of saw that the mainstream players in this 2003, 2004 space. So I think we're going to experience a similar trajectory. But you never know. But any comments with you guys? Yeah. Okay. Cool. So this works better on my computer. It's the first time using this whiteboard stuff. I saw it and it looked pretty cool. So bear with me. What is blockchain technology, right? So the basis of a lot of the driver of Web3, certainly Web3 doesn't have to have blockchain, but I think a lot of people agree blockchain is really the catalyst, if you will, that's bringing this change, the technology. And the basic 3 ideas of blockchain is this distributed database, or you can use ledger, but I want to say database because even though the database for like Bitcoin, for example, is a ledger, but there's other blockchain technologies that use the database for different things than just the ledger. And then there's a consensus mechanism. So we've got all of these computers sharing this database and keeping it in sync. Who gets to decide who gets to write to that database, right? So we need a consensus. We need a way to form a consensus that who writes to it, who validates that this is the actual database, right? Because we're in this permissionless environment. And then finally, cryptography. And cryptography to the point of how do I, and it speaks to identity, right? When Alice wants to send money to Bob, how do I know Alice is Alice? How do I know Bob is Bob? And how can this distributed ledger properly input that transaction so that everybody knows who is who and what money is going where? And there can't be things like double spending or attacks on the network, et cetera. So cryptography really helps solve that. So a distributed database, again, a couple of things to understand about that. You may have used databases like MySQL or Postgres or other databases, and most of them are mutable. Mutable means that I can create a record, and then I can go at a later time and edit that record and change that data. A distributed database in the blockchain is immutable, which means once that record is stored in that database, it cannot change. And the only way you make changes is to append records to the database. Like a ledger in accounting, right? You keep track of the debits and credits. So in the bank, you use this all the time. Anytime that you make a transaction as a service, there is a ledger that's keeping track of it, and arguably the way that you find out what your balance is in the bank is to basically run a report against that ledger, right? So you don't, you have your money in the bank, it's not in your house. So if you want to know how much money you have to go to that bank some way and run a report, and it's running it against their database. So imagine this public database that's available for everybody, read-only, and only particular nodes can write to it, but they need to have consensus to write. So for example, in Bitcoin, every 10 minutes, a batch of transactions get packed up. And you might, and this has been around for a while, so it may be old, but blockchain. What does blockchain mean, right? So you have transactions that are going into the database like a ledger, and instead of, storing one transaction at a time, these blockchains, they batch them together as maybe 1,000 transactions, right? And once they batch these together, they form a block. So all a block is 1,000 or multiple transactions that are ready to be added to the database. And then the way that they add them to the database is they take a link or link back to the last block, the last address of the last block, and then they write that block with that link. So it creates a chain. Right? So you have a block of transactions, and then a link, and then another block of transactions, then a link, and then another block. And this whole chain connects using cryptography. So if anything changes in any one of those blocks, the whole thing becomes worthless. So it has to be append only. And it has to have consensus on who gets to write it. But does that make sense? That's why it's called blockchain. So you've got all these transactions. Alice pays Bob. Bob pays Trip. Trip pays Tyler. Going on. Put those in a block, and then that gets written every 10 minutes in Bitcoin to the blockchain, which means every 20 minutes, all the computers that are nodes in the blockchain has the latest information. So it's completely distributed. Is anyone struggling to connect those dots? Yeah.
I am a little bit.
Yeah.
So who is it that is connecting the blocks? Does it automatically happen,
Yeah. So that's a great segue into the next piece. So great. So yeah. Who is the authority? There's no central authority, right? There's no one making that decision. So who gets to write a block? Does anyone want to take a stab at that? Everyone? Maybe. Anybody else?
The miners that reach consensus.
Okay.
Does it depend on the protocol?
It does. Yeah. There's a consensus mechanism. So mechanisms or algorithms are rules of engagement, right? And each blockchain technology has specific rules of engagement. And I'm going to be talking about two, proof of work and proof of stake. In order for trust to happen, there needs to be a way to determine how the blocks get written, right? And this is a consensus. And what happens in Bitcoin, and I'm going to explain it at a high level, but basically there's these nodes on the Bitcoin network that are competing to write that block. And the way that they compete is they try to solve puzzles, cryptographic puzzles. The first miner, and that's the term of the miner, is these computers that are competing to write that block because they get paid in Bitcoin. If they write the block, they actually get paid in Bitcoin to make money. So they are running this puzzle, and if they solve that puzzle and submit it, then all the other machines can quickly verify that they solved it and give them permission to write that block. So there's a common game theory called the Byzantine generals theory. And basically, if you have a general and he's got 5 armies and they're all going to the castle, 3 decide to attack the castle, 2 groups decide to retreat. How do you get a consensus, right? How do you formulate a consensus where they all attack or they all retreat? And that's kind of the pattern at a high level that Bitcoin uses. And it's called proof of work. Okay. So you may have seen or heard of the term miner, but all a miner is a participant in the network that essentially tries to solve these puzzles. And these puzzles are high compute. So you may have heard, Bitcoin is bad for the environment, right? It generates a lot of energy. These are these machines that are solving these puzzles so that they can, quote, mine Bitcoin. And you may have heard Bitcoin is digital gold, right? How do you create gold? You don't create it, you dig it out of dirt, right? So this is like the computer version of digging value out of dirt. You are spending energy to create the capability to write to the database. And many people have called out Bitcoin for it being slow. And you'll hear terms like layer 1 technology and layer 2 technology, which we can get into. But the core thing is the way proof of work works is a miner or a computer that's participating on that network is solving puzzles to get the opportunity to write that block to the database, right? Let's say you had an Excel file, right? And everybody could read it, but only a few people could write it. And those people had to run around the building 3 times. The first one that ran around the building 3 times got to write to that spreadsheet. That's what's happening. Yep.
Where does the value of having the privilege to write the block come from?
Right. So it is, and I don't want to get too much in money, but it goes into this value of trust, right? Trust. Money is a social contract, right? A social contract that, you know, I've got this corn and I think it's worth $10, and you may have tomatoes and you think that's worth $10. So we're going to use this technology called money to trade it. So far, so good. So what Satoshi Nakamoto did was set up a scarcity algorithm where, you know, the perceived value, which is based on a social contract, is kind of developed with this currency. Like how did the dollar get valued at $1, right? Eventually, you know, at one point it was backed by gold, but it's not backed by gold anymore. So how do we know that $1 is actually worth $1? Right. So it kind of comes from nowhere, right? It comes from this vapor space, and the fact that every node in the network trusts in that currency, it has value. So anyone want to?
So the miner that solves the puzzle first gets to write, what's the mechanism that ensures that what's written is accurate?
Yeah, and we'll dive in that a little bit, but basically, so the miner gets to write. How does everyone validate or verify that that was correct, that the miner wrote the correct block? And that's where cryptography comes in, and this concept called hashing. And basically, in order for this to work, the writes are going to be slow because you're solving puzzles, but the reads need to be very fast. You need to be able to validate or verify that these transactions are accurate very fast. So there's a technology called hashing that can take a data input, run it through a function, and create a fingerprint that's very easy to look up, very quick to look up. And we'll talk a little bit more about that. But you're absolutely right. You know, in order to have trust, number one, when it gets written, more than one computer needs to be able to validate it, right? The whole network needs to validate it. And that can prevent mass takeovers, right? So in 2017, 2018, there were all these things. So what if China kind of takes over Bitcoin? Or what if some bad actor comes in and takes over 52% of the machines? Can we trust it, right? And over the last 12 years, I think Bitcoin has held up pretty well. There's another kind of model. Yep.
Is a miner are they doing any work, or are they just turning on the computer?
Yep.
I mean, are they having to set up the computer and do anything?
No, it's all automated. Yeah. So there's actually that they use these huge farms of ASICs. Anyone know what ASIC stands for? It's like asymmetric integrated circuit or something like that. But basically, it's a computer completely designed to do nothing but solve puzzles, right? And they've got thousands of them. So, and then it gets a little bit more complicated than that. There's these pools of them, right? So there's all kinds of kind of complexity wrapped around that. And I think it's kind of too deep for this, but at the end of the day, these computers are working, solving the puzzles, and when they solve them and everyone verifies, it gets written and then they get paid. Okay? So the other one is proof of stake. And proof of stake, so proof of work, a lot of energy. I think the energy for Bitcoin is comparable to the same energy usage of Ireland or something like that. It's a lot of energy. A lot of proof of stake is a different kind of consensus mechanism. Proof of stake model, many entities run a program known as a validator. Validators play a key role in maintaining and securing the blockchain. basically they're responsible for processing incoming transactions, writing to the block, as well as voting on and appending new blocks. So they vote. It's a very democratic-like mechanism. And one of the nice things about this is it's very low energy, right? It does not take a lot of resources to run a validator. You don't need extremely fancy hardware to do that. It's not a race. It is basically how much stake you have in the technology. So if I have 10 chips and Tripp has 5 chips and Tyler has 5 chips and a transaction comes on, because I've got more stake, I'm most likely to win and write that transaction. But, yeah. Sure.
So, we're a proof of stake here. I think I just have a really practical question, which is, there are millions of transactions happening. How is a node operator or a validator able to process all those, validate them, how does that happen?
Yeah. Yeah, it's a great question, and I think right now Bitcoin and Ethereum are both proof of work, and they're probably the most biggest technologies out there. The one that I study the most is Solana, and they're able to do, I think, like 47,000 transactions per second, and as far as how they do that is very, it's probably too deep for me to explain from a technical standpoint, but because it's at that OS level, but they basically leverage a lot of OS capabilities, dealing with memory, CPU, et cetera, but still around that cryptography kind of signing, digital signing. And they're able to work in a multi-parallel process way, but then by leveraging timestamps and leveraging hashing, they're able to essentially resolve their data sets and make sure they're secure when the transactions are written. No, it's a great question. And I wish I could explain it as well as proof of work, but this is something that has been a struggle for years. And yes, sir.
So I have a question. I have a student that was asking, and he's really interested in this, and he's wanting to try to buy a simple mining operation, something that's cheaper to learn, but seeing that they're moving from proof of work to proof of stake, I mean, is it really a good time for him to invest in some technology, not knowing that that may change over and maybe affect maybe his investment?
Yeah, that's a great question. So my opinion is Bitcoin, that's big boys. There's you're not going to get much traction now unless you have special hardware and a ton of it. There are other proof of work networks out there. One comes to mind is Arweave. And Arweave is really interesting. Happy to talk about that. But there are some out there. You just want to do your research and understand the mechanism. Ethereum's moving to proof of stake, right? So there's going to be a huge battle between the miners of Ethereum as they cross that chasm. Solana is proof of stake, and I think they're a good model to look at on how you do validation, which is the equivalent of mining in the proof of stake model. And there's all kinds of other proofs. These are just like the 2 most popular, but there's all kinds of other ones. And one of the neat things about this technology is the way that the network stays secure is incentivizing the network nodes. So there's got to be an incentive mechanism for people to store that data, do these transactions, and that's what these consensus mechanisms help provide.
Does that not take away, like, when you go from proof of work to proof of stake, doesn't that take away from, like, having it controlled by everybody versus having it controlled by a few?
So, yes and no. Yes, in a way that if you have the most stake, but there are limits and rules on how votes are weighted so that in a proof of stake model, no one could ever get more than 51%, right? So there's just rules in place to prevent that from happening. Okay, so part 3 is cryptography relating around security and identity. And this is probably, if you're okay so far, if everyone's mind is not blown, this might hurt a little bit. This might, you might want to go get some coffee after this because we'll go a little deep. But stop me if you totally get lost. So we're going to cover 3 pieces. And this is really important to understand at a high level because we're going to go into something to a wallet and we're going to speak on identity and how do we make sure that you're you on this network. So these are the building blocks of that. And there's a hash function and asymmetric key pairs. Is anyone familiar with key pairs? Public key, private key? Okay, good. And then signing and verifying. So the hash function. A popular one is SHA-256. It's a one-way process that takes any data and creates a fixed set of characters that unique identifies that inputted data. So in this example below, I take hello world and run that through a SHA-256 converter, and I get this character string below. This character string is completely unique with that SHA-256 algorithm for hello world. In other words, I can pass this character string to anybody here, and you can type hello world and run it through the SHA-256 converter, and you'll get the exact same string. But you cannot, from that string, derive hello world. So I could pass it to Trip, and if I didn't tell him that it was hello world, he could not derive that was hello world. So I have a little link down here to a simple 256 generator, right? And if we type hello world and hit generate, we should get that exact same hash. So when we're storing data in the databases, in the blockchain, we're storing a lot of these hashes. And we're hashing those together with a timestamp, with a message, and a nonce, a random number. And then we link those in the database, and that's how we can validate very quickly if things are authentic, because we're using fingerprints and not reviewing all the data. Does that make sense?
There's other technologies that use the concept, so like GitHub.
Yep. GitHub, when you log on to any site, if you're using technology like JSON Web Tokens, they use this to sign transactions back and forth. Yeah, it's used a lot of places, but it's very helpful for creating trust. Everybody okay with that? A hash function basically takes any data and creates a fingerprint of it. So I'll use an example that an MIT professor used. If you ever do a crossword puzzle online, like the New York Times crossword puzzle, you put all the answers and you want to verify that it's correct. Doing that online, how fast does it take you to verify if that crossword is correct? It's kind of instant, right? It doesn't take a day, it doesn't take whatever, it's instance. Because beforehand, someone filled out that crossword puzzle, took all the answers, ran that through a hash, and then when it checks your answer, it just runs that hash. And if it matches the same character set, then it knows you got it correct. If it doesn't match it, it knows you got it incorrect.
So you can't reverse engineer a hash?
You cannot reverse engineer it. Well, there are some algorithms that have been broken, which, again, can. But you could take a full movie and, this data hello world, it could be any kind of size, run a hash to it, and if anything changes in that hash is going to change. But the hash will always be fixed length. So this one will always be 256 characters. Yeah, I'm just talking at a high level. There's a lot of nuances, but for the purposes of this, I think that's a good sound thing. So
It helps guarantee the value that items in the chain haven't been messed with.
that's correct. That's correct, right? So all these people are sharing this database. What if Tyler decides to go up the chain and change, instead of pay Trip, pay Tom, right? Well, when someone else tries to validate that, because the hashes generated are different, that's going to show a red flag. And they'll know not to trust Tyler's database, right? So in cryptography, a common practice is verifying. And that's what we're talking about, verifying a message, verifying a transaction. We use hashes, and we use these concepts called public and private keys. A key is just a string of text, and basically public and private. Does anyone know the difference between public and private keys? A key is a string of text. What's the difference between public? What's a public key? What can I do with that? Yeah.
Send me something, I give them my public key.
Right.
Use that.
Kind of serves like your identity, right? For your key pair. It's an identity identity label, right? What about private keys? Should you give your private keys to anybody? No, never. Some people would say, should you store your private key on your computer? No, right? Private keys are private. And the combination of those is how you can prove identity on a network. So, yep.
Are either public keys or private keys stored to a specific node or assigned to a specific node?
So most of the time, you will keep public keys and private keys in a wallet. So when you think of a term of a wallet, and I know that's might be a hard concept, but a wallet is really just storing your public keys and private keys. And then if I have my public key, because this is an open ledger, open to the network, I can take my public key and go to any database on the network and look up my account and see how many Bitcoin I have, right? But anybody can do that, right? Anyone can take that public key and query the Bitcoin database to find out how much Bitcoin you do have. Private key, I can create a transaction. So if anyone has that private key, guess what they can do? They can go to that ledger and say, on the behalf of Tyler, I want to extract 1,000 Bitcoin and move it to this other address, right? So that private key, if someone gets that private key, then it's like someone has hacked into your bank account. They have full control of all of your permissions in that network.
If that happens, can you change your private key forever?
Well, if you move to another private key before that happens, but once someone has that private key, now saying that, there's been in the news that you may have heard the ransomware, and people have done the ransoms, got paid in Bitcoin, and they have been able to go and get like 90% of it back or whatever. I don't know how all that works, but it would be very hard. Yep.
You're talking about everybody being able to see all the transactions, and everybody knows who has a certain amount of Bitcoin. That's when they're saying, I got this whale that just moved all this stuff, because everybody can see that transaction. So it's not like I went to my bank and I took $1,000 out. Only I know I took $1,000 out of the bank, but with this technology, everybody knows who's moving money around, supposedly, right?
Right. It's completely transparent, so you can see it. But again, if I have my public and private keys and I have them in a wallet, I don't necessarily have to proclaim that I, Tom Wilson, is associated with that public key. So they can see that public key, but there may not be a direct trail to you, the person who has that public key, and hopefully no one can see your private key. But yes, they can see money flow through the ledger, absolutely.
We use these same kind of keys with HyperCloud.
Yep. Yeah, a lot of services use these to create security. So when you log into Facebook or when you log into Google, behind the scenes, you're using these keys. Also, when you go to a browser and you go to HTTPS, right? It's using these keys to create encryption and decryption, and it's all happening behind the scenes. You're not responsible for those keys. The servers are, right? So when a server is provisioned in the cloud, it's responsible for keeping its private key private and creating encryption between. And your browser has private keys, and your operating system has keys. That's how all these things kind of communicate with this kind of encryption and decryption model. Let me try to walk through an example. So Alice wants to send a message to Bob. Okay? So if Alice writes the message and just post it on Twitter, can Bob see the message? Yeah. Can everybody on the internet see the message? Right? So how would Alice send a message that only Bob could see? So what Alice would do is Alice would take Bob's public key and encrypt the message, then send it to Bob, and then Bob would take his private key and decrypt the message, right? Now, can Bob read the message? Can everyone on the internet read the message? Okay. So if Alice had Bob's public key and encrypted the message and put it on Twitter, it's just going to look like a bunch of characters. And then Bob goes and reads Twitter, grabs that, and converts it with his private key. He'll be able to see what Alice said. Now, can Bob prove that Alice sent the message? I could be Alice. Tyler could be Alice, right? If we had Bob's key, we could pretend to be Alice, right? So the way that we solve that is we use some key pairs where Alice signs the message. Let's see if I got it. Yeah. Alice takes her private key and signs the message. Bob has access to Alice's public key. So when he decrypts the message, he can verify that this message was signed from Alice. You may remember back in, I guess it was the late 90s, where a fun thing was because email is unsecure. So a fun thing was people to send emails as the president at whitehouse.gov, right? And people would get the email and say, oh my God, the president sent me an email, right? Well, that goes on today. It's called spam, right? You get a lot of unsolicited junk. But, you know, and some people get their emails compromised and they can actually, you know, seem like that person. But the gist is that's how transactions are kind of trusted on the network, is if I sign the transaction with my private key and submit it to the Bitcoin network, then the Bitcoin network can use my public key to validate that that was an authentic transaction. That make sense? Everybody okay?
Can you talk about why, if Alice signs a message with her private key, and Bob can verify Alice's public key, how does her private key stay protected in signing?
So yeah, and that's where we get into wallets. So like I said, private keys need to be protected. You do not want to share your private key with anyone, right? Or they could sign a transaction for you.
The two things are generated, public and private key are generated at the same time.
Right.
On a common value. So, there's a relationship between the public and private key, but private key is not shared.
Right. So, and that leads us into wallets. So we'll talk about wallets, and that really, I hope will answer your question. If not, let me know. So wallets. So we've talked about how the computers work and all of that, but how do people interact with this stuff? And I'm getting there.
I think you can do two-finger scrolling.
No.
I made it work.
Yeah. Okay.
I think it's gonna flicker.
Yeah. It's this Mac. So digital wallets. So how do you manage these public and private keys? And I know wallets, you think of your wallet in your pocket. It has money in it. But these wallets can contain all your digital ownership, right? They manage your private keys and public keys, and it allows you to do 4 things. You can sign transactions. You can verify transactions, right? So if someone sends you money, you want to verify that it came from that person. You want to verify that that message came from Alice. You want to verify that it didn't come from Tyler, right? And then you can send and receive transactions. Those are the 4 key things that wallets do. There's 2 types of wallets. There's custodial, hosted, which means you're trusting a third party with your keys. You're trusting a group, like, and there's 3 I know off the top of my head: Coinbase, Gemini, Crypto.com. These allow us consumers to participate in networks, blockchain networks, without having to worry about losing our keys. They're going to manage our keys for us, right? Now, that may be a good thing, that may be a bad thing, but you should definitely do some research and check that out. So most of them have mobile apps, and when you use their mobile app, you are not storing keys on your phone. If you use their desktop app, you're not. They are hosting those. They are also hosting your money. So that's very much like a traditional bank. And then there's non-custodial wallets. These are wallets that you are control of. There is no bank. There is no third party. If you lose your keys, they are lost. If someone finds your key, your private key, then they can become you, right? But you can easily monitor and control the activity, and no one can kind of dip in and take your funds without having access to your private keys. Whereas a custodial wallet, now, believe me, security is their very much prime directive. But if someone was to come in to that hosted solution and somehow get access to those private keys, they have access to all your stuff, right? So there is risk there. And there's risk with non-custodial wallets. The risk with non-custodial wallets is how responsible are you, right? And how responsible are you at managing your keys? And there is a huge amount of people that are trying to get access to all of your stuff digitally. I don't know if you get bad text messages these days or bad emails. They're like, click on this link, and they're just trying to figure out how to get your passwords or your social security number or your credit card numbers to do bad things, right? So you know, non-custodial wallets, you have to really do some research and really know that you're responsible for that, right? And when it's gone, it's gone. There's no coming back. There are different types. There's browser-based extensions, where these browser-based extensions actually hold your keys in your browser. And you can do transactions and work with dApps, decentralized applications, using these browser-based extensions. And then there's hardware devices like the ledger or the tracer. These little devices actually hold your keys so they never touch the computer. And then when you want to do a transaction, you plug it in the computer or connect with Bluetooth, although I wouldn't recommend using Bluetooth. But you do that at the time of your transaction and you sign it. But that's called cold storage. That means those keys are off the network. They're off the grid. And that's probably the most secure way to manage it, in my opinion. And then there's mobile apps. Mobile apps, they'll hold the keys on your mobile phone. As long as you don't lose your phone, you have your keys. And then there's desktop software apps. So these are all built for us to manage these keys in a sane way.
What storage mechanism on the browser-based extensions?
So your private key, there's a algorithm called I think I'm gonna say it right, mnemonic, and you'll see when you create a wallet, you'll get 12 secret words or seed phrase, or 24 secret words or seed phrases, right? Those words actually, the first 4 characters of each word actually combine to create your private key. Okay, so you want to take those and put them in a safe place, so that you don't lose them, because that is your mechanism to restore that. And you can restore your private keys anywhere, whether it's browser, hardware, mobile, desktop, by using that seed phrase. As far as where they store them, they encrypt them and store them probably in the database in there, and it's not level DB, but index DB. But because they're an extension to the browser, they're sandboxed, so nothing can get in to that sandbox. Okay. So we don't have time to do the full demo, but I will try to show you a little bit of the demo. So again, I use Solana, and I just want to walk through an experience of creating a browser-based wallet and showing you how you can send money or receive money in that wallet. So let's see here.
So can I just, while you're doing that, kind of clarify my last question?
Yes.
So
Thank you.
To do the verification.
Correct. Yep, yep. Let's see. I wanted Chrome. Okay, thanks. Okay, and if you do have to run, I really appreciate your time today. I hope you learned something. I'm going to just do this demo just for people that are interested on kind of visualizing how these wallets work. This is a browser-based wallet for the Solana network. I'm going to add that to Chrome. And again, it's a Chrome extension that you install, and it kind of lives in your browser. So we're going to add the extension from the Chrome Web Store, and it's going to pop up in our browser, and it's going to walk me through creating a new wallet. So I create a new wallet, and here's my secret recovery phrase or seed phrase. If you're creating a wallet for real, you want to write that down. Whether you create a hardware wallet, mobile wallet, or a browser extension wallet, you need to write that down. I'm going to skip it, so because this is just for test. And then I will, with a browser extension, create a password, maybe. And agree. I know.
You feel like Chrome is better than Safari or Firefox?
I like Brave. Yeah. Brave has built-in ad blocking, has built-in privacy, and built-in privacy with Tor. It really is focused on your clean, secure experience. Okay, so we finished and created our wallet. It's going to show up in this little extensions tab. And I'm just going to pin it on the browser so I have a little access here. And here's my wallet. I have 0 in. And what I'm going to do is move to the test network so that I don't have to play with real money. So I'm going to call this test. And I'm just hitting the settings right here. And then I'm going to go down to change network. And I'm going to choose the test net. And what that'll do is allow me to play moving money on the network without real money. So I'm going to do that. And now I've got my wallet, and it's got this address. So if I copy this address, this is address derived from my public key. So that address is kind of derived from my public key. And I can give that address to anyone, and anyone can send me money, can send me Solana tokens. So what I'm going to do is go to what's called a faucet and do that. This solfaucet.com, I'm going to send a single token to my new wallet. So solfaucet.com. And I'll just paste in my wallet address, and I'm going to send to the test net 1 sol. Okay? The reason I like Solana is that's fast. That is a fast transaction. If you've ever worked with Ethereum, it can take up to 30 minutes to resolve. If you've worked with Bitcoin, it can take a little bit longer. So let's look at our wallet up here. And we should see our balance. We've got 1 sol in there. And what I was going to do for fun, but we're running out of time, was allow someone to post their address on the Miro board, and I would send you some sol to have fun. But you can play with this when you have some time. This is being recorded, so I encourage you to watch it and just create a wallet, play on the test net. Again, this is kind of foundational. And once I have this wallet, this is my own bank, right? I've got $228 of fake money, monopoly money, that I can go to some application and sign on and spend that money. Yep.
I was gonna ask, okay, say I was doing this in class, is there a way to set up, you're probably gonna say, yeah, there already is this, like, set up your own little, market there where it goes up and down, so your class can kind of see, like, the money's changing in real time?
Yeah, so there's all kinds of tools on these blockchains where you can visualize that, and you just go to one of those tools and click the testnet or devnet, and you can see those transactions going. And all around the world, people are experimenting because developers building apps are using this to test their apps before they go live. You can also run your own kind of fake network and do the same thing. That takes a little bit more effort, but you can do that. Any other, Jim, you had a question?
Transferred one Solana,
Yep.
and that equated $227.97.
Yep, that's the market value of one Sol token at this time. It's $227.
And that increased in value by, what, 0.13%? Or what is that?
Yeah, that's just showing that it's increased by 29 cents since it was added to your wallet. Yes, sir.
Beyond the scope of maybe today, but just like we have a monetary system where we've got euros, dollars, yen, et cetera, right? And they all float against each other. Is the cryptocurrency doing the same thing, and is it tied back to our existing currency?
Yeah. So again, kind of the dollar is the standard. So you'll see a lot of currencies always showing value at the dollar, but you can change that and see it as it relates to the euro and et cetera. So all of that, there's actually a term called stable coins that are actually cryptographic coins you can purchase that their whole focus is to be one-to-one with the dollar, right? And we'll get into some of that. Yes, sir.
Can you do interchangeably like Bitcoin to Sol or vice versa?
Yeah, so there are apps on these networks that allow you to swap. And you can swap Sol to Bitcoin or Bitcoin to Ethereum, right? And you pay a fee for that, but yes, you can exchange. And then within each network, you may have heard a few years ago about ICOs, like initial coin offerings. Like the Ethereum network allows you to create tokens within the network. Solana allows you to create tokens within the network, and you can trade within that network tokens. Like Doge is an Ethereum token in the Ethereum network. So you can buy Dogecoin with Ethereum and then transfer your Dogecoin back to Ethereum, right? But if you want to do cross-chain, there's applications that allow you to do that too.
Solana is the one that is not proof of work.
Yes, Solana is proof of stake. Bitcoin's proof of work and will always be proof of work. Ethereum is proof of work now, but they're going through a transformation, and a year from now, supposedly they'll be proof of stake. Hashgraph is proof of work. Proof of stake. Sorry, proof of stake.
Where do you see it settled? Or do you?
Well, I think Bitcoin will always be proof of work. I think there's a term called Bitcoin maximalists where they're just very set on this is the way. And it's a, again, you can form a lot of opinions about these, but I think their kind of focus is we want this to be digital gold. We want it to be more scarce than gold. And they're only going to print 21 million Bitcoins. Once that 21 million is printed, that's it. No more Bitcoin, right? There's other networks.
How do they pay the miners?
Well, then there won't be any miners, right?
Transaction fees though, or?
There are like tips, and you'll have, I think you'll have a lot like proof of stake pools where people will get tipped to process transactions. And there's a There's a network on top called the Lightning Network, which makes Bitcoin fast, because Bitcoin as it is really slow. So the Lightning Network is where the new mining is, if you will.
So it isn't like even the value of Bitcoin has gone up, but like each time you solve the puzzle, you're getting less money in return. And that's kind of the other part of that game where you should get more money every time you solve the puzzle out of your state.
Yeah. It's a deflationary strategy, right? So as Bitcoin goes, instead of inflation, where your value of your dollar kind of gets less over time, Bitcoin is deflation. So the value of a Bitcoin should get more over time because of the scarcity model. That's why you hear people saying Bitcoin's going to be worth $1 million in 10 years. Things like that. Great. Well, thank you all for coming. If you have any questions, please hit me up on LinkedIn, twilson63. And hopefully for those who are coming back next Wednesday, we'll dive into smart contracts and tokenomics. So hopefully this exercised your brain enough and get some rest. And then next week we're going to go down the rabbit hole some more. Thanks.
Thank you.
How was that? Oh, I brought some Hyper t-shirts if anybody wants a t-shirt. Cool t-shirts if anybody wants them.